The discovery of microplastics in clouds may have far-reaching consequences on the weather, and the implications are far from positive. Microplastics are becoming more and more ubiquitous, appearing in everything from the depths of the ocean to the tops of mountains and even the air around our cities. In a recent study published in ACS Environmental Science and AMP Technology Letters, researchers have delved into the presence of microplastics in clouds above mountain ranges. Their findings indicate that these minuscule particles may have a significant impact on cloud formation and consequently weather patterns. The production of microplastics, plastic fragments that measure less than 5 millimeters, stems from a wide range of commonplace items such as clothing, packaging, and even car tires. In the ongoing evolution of the field of study, researchers are not only discovering microplastics in the air, but also delving into their potential involvement in cloud formation. For instance, Japanese researchers recently discovered plastic granules with surfaces that attract water in mountaintop clouds. Yan Wang and colleagues sought to explore this topic further by investigating the presence of microplastics in mountain clouds, utilizing computer models to determine how they could have gotten there, and conducting experiments to study how these particles could have impacted and been impacted by the clouds. The initial step taken by Wang and their team involved the gathering of 28 liquid samples from clouds situated at the peak of Mount Tai, located in the eastern region of China. Upon analysis of these samples, they discovered the following. Microplastics were found to be more prevalent in clouds that were denser and at lower altitudes. Common polymers such as polyethylene terephthalate, polypropylene, polyethylene, polystyrene, and polyamide were the primary components utilized in the creation of particles. Most of the microplastics found were less than 100 micrometers in length, though there were a few outliers that stretched up to 1,500 micrometers. According to the researchers, particles that were older and more abrasive had an increased amount of oxygen, lead, and mercury attached to their surfaces. This could potentially support the formation of clouds, as per their hypothesis. In order to determine the origin of plastic particles found in clouds near Mount Tai, Wang and their team devised computer models that simulated the travel of the particles. The models revealed that the particles predominantly originated from inland areas with high populations, rather than from the ocean or nearby mountains. The team conducted laboratory experiments, which demonstrated that microplastics exposed to cloud-like conditions, which included ultraviolet light and filtered water sourced from clouds, had smaller sizes and rougher surfaces compared to those exposed to pure water or air. Moreover, the particles exposed to cloud-like conditions contained higher levels of lead, mercury, and oxygen-containing groups. These outcomes indicate that clouds have a significant impact on the modification of microplastics, which could potentially affect cloud formation and the distribution of airborne metals. The researchers conclude that further investigation is necessary to fully comprehend how microplastics influence the weather and clouds. To support our channel's growth and ensure broader awareness, kindly hit the like and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.